All right, so now that you've gotten pretty good at writing expressions from word sentences, turning them into number sentences, let's look at working with equations and inequalities. All we're going to do is write two expressions and compare them to each other. They're either equal to each other or one is bigger than the other. That's all we're doing. So let's look at an example. The difference of twice a number C and 10 is more than 42. Okay, well, the more than 42 is, is no more than 42. That part, that's the new part. So let's go ahead and take it out just so we can kind of look at the first part and see that it's what we've been doing all along. So the difference of twice a number C and 10. Well, we know to look at the difference, right? That's just subtraction. So that's our operation word, the difference of, and we need a this and that. Well, here's our and, right? So this and that, well, that is clearly 10, but this is bigger than 10. It's twice a number C. So how would we say twice a number C? Well, twice just means multiply it by 2. So, okay, I can't seem to capture exactly what I want here. There we go. Twice a number C. This is 2 times C. So let's say it again. Let's look at it again. Our operation is difference, so subtraction of this is twice a number C, and that is 10. Now let's put the other part back in and see what we end up with. Is no more than 42. So is no more, that's just a comparison. That's just saying, I could say equals 42, right? But this one doesn't say equals. This says is no more than 42. So I'm going to write this over here prettier. 2c minus 10, some kind of a comparison to 42. Now let's think about what is no more than says. If the thing on this side of the equation is 41, so suppose, that's what this little fat cheeky s means, suppose we get the number 41. Right? Suppose the answer is 41. Does that fit this? Well, is 41 no more than 42? Of course it's no more than 42. It's not even 42 yet, so it can't possibly be more than 42. How about 44? Is 44 no more than 42? Well, no. It's definitely more than 42. So we're seeing a pattern here. What about 40? Is 40, could I say 40 is no more than 42? I could say that because it's not even 42. How about 42? Okay, 42 is no more than 42. Well, yeah, it equals 42, so it's not more than 42. It's exactly the same thing. So I'm starting to get a feel for this. I want to say that the things on this side, on the left-hand side, are smaller than or equal to 42 because these numbers are smaller than and this number is equal to 42, and that's what fits in my scenario. All right, let's do another one. All right, so let's break this down. We have the difference of 32 and the quotient of a number m and 7 is. Holy cow, that's a lot going on. But clearly I have a comparison. Is 80. Is, that would be equals 80, right? So whatever all of this gobbledygook on the left-hand side is, we know it is 80. Okay, that's part of it. Now, I have a difference and I have a quotient, but we want to start from the left to right. The difference, done, this and that. Oh, of 32 and, there's my word, 32, and the quotient. That tells me that I'm going to have some other this and that going on, where the quotient has to do with division of a number m, and there's my and, right? There's my little this and that word, of a number m and 7 equals 80. So now I can put it all together pretty. 32 minus m divided by 7, because I like it better when it's written that way, equals 80. So now I've converted a number or a word sentence into a number sentence. One using an inequality, and one, let's do one more because these are kind of hard. I think an example, the more examples I can do, the better. I'm only doing one more. The difference of a number m and 4 is greater than 4 and less than 10. Holy cow, that one looks really hard. So this is a case where we have something that is greater than 4 and also at the same time less than 10. So we have to find a way to say both of those things at the same time. But let's not even worry about that part yet. Let's just worry about this side, because I think we can work with that side and worry about the other side next. So the difference, done, of a number m, and 4. Done. That part's done. M minus 4 is greater than, well, that means we're saying that this is bigger than 4. So all of this has to be bigger than 4. But at the same time, it's less than 10. What? Oh, that's one of these where you write on both sides, right? This is smaller than, so you point toward the smaller thing because the alligator eats the bigger number. So this thing on the left-hand side is smaller than 10 and at the same time bigger than 4. Now, we like to write it in the other order where we're not doing greater than symbols. We like to write it in this order. 4 is less than m minus 4. So notice I haven't changed anything. I wrote these in the opposite way, but I still have the alligator eating the right thing, right? The alligator's eating the m minus 4. And the same thing on the other side, I'm going to have the alligator eat the 10. And so this is a compound inequality. It has two things going on at the same time. All right, so now that we've put together equations and inequalities, what on earth are we going to do with them? Well, we're going to use them to solve real-world problems. Granted, in Algebra 1, the problems that you get when you get finger quotes, word problems or real-world problems are very contrived and not very realistic. But they do get us ready to start understanding the real-world problems that we do want to solve later. So let's look at a couple. So we have 11x minus 4 equals 18. Well, all this is an equation, right? We could actually write a number sentence to go with this. If I saw this, I would say, well, difference, because it's subtraction, of this 11 times a number x, and because this and that, and 4 is 18. So I could say find, or what is the, or let me see, how would I say it? I would just say the difference of 11 times the number x and 4 is 18. Okay, but we were lucky they gave us the equation, and so we can slam straight ahead. First thing we want to do is talk about notation. You're going to be given problems that look like this, followed by a semicolon, and for example, the number 2. And really, all we want to do is we have an unknown value here. In all of these, we have some kind of an unknown value, and our job is to figure out what that value would have to be for this equation to be true. If I didn't have equals 18, I would just have an expression, 11x minus 4. But in this case, I have equals 18, which means that I can figure out what x is, what a number x is. So we want to solve a problem or work on a problem. This is actually called evaluate a problem by plugging in this 2 for the x. What we're trying to find out, this shorthand means, is 2 a solution to this equation? So I'm going to plug in 2 for x. I'm going to trade these out. So that would be 11 times the thing I'm going to substitute minus 4 equals 18. So over here, I know that I want to try out 2 for x. Then solve it. Well, 11 times 2 is 22, minus 4 equals 18. So at this point, all I'm doing is trying to find out, are they actually equal to each other? Because if 2 is the right number to substitute for x, meaning in this situation, if x equals 2, then I'm going to end up with something that looks like 18 equals 18. And so that's where I'm trying to go. And so let's take 22 take away 4. Well, in fact, that is 18 equals 18. This is called an identity. And the word is being used exactly as it would if you were talking about yourself, your own identity. 18 is 18. Marla is Marla. Sam is Sam. Henrietta is Henrietta, right? That's an identity. 18 is 18. So 2 is a solution. Yes, 2 is a solution. Okay, so you'll solve a bunch of those, or you'll be asked to determine whether any given number is a solution. Let's look at an example where it is not a solution. So we have 6n minus 5. This would be the difference of 6 times the number n and 5 is greater than and equal, or greater than or equal to 13. Semicolon means we're going to test this value to see if that is a solution to this inequality. So again, all I'm going to do, put parens around my variable, and then rewrite my formula, leaving a hole for me to substitute that 15 in. Put in the 15. So 6 times 15, yikes, what is that, 60? 6 times 5 is 30, so it'd be 90, minus 5, greater than or equal to 13. 85 greater than or equal to 13. Well, darn, I thought I picked one that wasn't true, but that's indeed true, because 85 is definitely a number bigger than 13, so that is also true. So yes, 15 is a solution. Okay. And last but not least, at least for today's lesson, you'll be asked to use mental math. To solve an equation. So 17x plus 2 equals 36, and you have to ask yourself mentally, so what number, well, 17 times something plus 2 equals 36. That means 17 times x alone has to equal 34, because this 2 could be taken out of the 36. 17 times what equals 34? Well, 17 times 2 equals 34. And then you'll have to check your answer. So we have 17, because I'm substituting for the x value, plus 2 equals 36. 17 times 2, and we're not sure. We think we have the right answer, but we're testing. 17 times 2 is 34, plus 2 equals 36, and 36 equals 36. That means I got the right answer when I used mental math.